Hey guys, and welcome back to the channel. In today's video, we're going to be taking a look at how I leveraged HTMX and Server-Sent Events in order to make this streaming LLM that you can run on your own machine. Now, the key thing here is server-sent events. And what exactly are server-sent events? Well, they're kind of the middleman between WebSockets and a regular HTTP request, with the difference being that A, they run over HTTP instead of WebSocket, and that they are one way. But in an application like this, you don't really need to have input streaming, right? Because we type our thing and then we send it in. So, what is a coup anyway? I'm sure everyone at OpenAI knows the answer to that question. Our messages don't need to be streamed, so it's fine. All we care about is that we do get updates in real time as the LLM is spitting out the responses. So similar to this, which it just stopped because I exceeded the amount of tokens in my context. So if I refresh this, what is a coup? I have HTOP open here on the right, just so we can kind of see the performance that it's having on this machine. And do keep in mind that I am running I'm running OBS Studio with it. So we can see that it streams out pretty quick once it gets the model loaded and all of that. So it's pretty straightforward. Normally when I'm not doing streaming or recording, it actually functions pretty well. But we can see that, it's capable of doing coding, it's capable of doing writing, it's capable of most of the things that you would do with ChatGPT 3.5. In the case of this model, it is Mistral 7B. You can see it's actually still going. This particular one is the version from The Bloke, which is just a converted version that he put up. So GGUF is a format for machine learning models that are quantized for use with Llama CPP. They also work with C transformers, which is what I'm using here. You can technically just go to Hugging Face. Hugging Face is like a GitHub distribution for machine learning models and data sets and pretty much anything AI you can find here. You can actually just copy this and paste it into what we're going to be working on next in order to download that model. I like to have them hosted locally in a way that I can find them. So usually I just download them manually, so you can go through the list and actually just copy and paste. The quantized models are usually one file, and that's kind of the good thing about it. So you can download a few different models, you can test a few different things. I should have gone with a smaller model for the sake of this demo, but I wanted you to see that it is indeed capable. I have called it Own AI because it's kind of fitting. It does have some repetition issues here because of the settings that we're using that are defaults. Since this is something that you're going to be coding yourself, then it is something that the prompts are going to have to be a little bit more involved than something like ChatGPT, where they already have a lot of that instruct prompting and fine-tuning happening beforehand. You can fine-tune these models yourself. That is an amazing thing to do. If you want something that's going to specifically write articles for you, then you can do that. If you want something that's going to filter your tweets, make a tweet that's more readable, marketing materials, starters for essays, all that kind of stuff. You can make prompts and technically your own GPTs for that sort of thing yourself. But you can see it did some Python stuff that actually technically should work. Responsive content, HTML parser, all that stuff looks like it should work more or less. But you can see it's very coherent. Mistral is the one that I feel is at the top of the game right now as far as smaller models that most people can run on their machines. 7 billion parameter model is what this one is, and that just more or less a general metric for the size of the model, for the information, and not necessarily the reasoning, but it's usually larger models tend to perform better within reason. But we're getting more and more of these models that are smaller that still perform very well. And I feel like 7B from Mistral is definitely one of them. If we go on the Mistral AI Hugging Face page, we can see that we can find some information as far as how they actually train the model, how you actually want to prompt the model, which is very important. We could see all sorts of metrics as far as what they use to train it and how many downloads and whatnot. When you're looking for models, if possible, most of them do have these kind of prompts available that you can go ahead and you can do a compute just to see how well it actually responds to what it is that you want it to do. So write a poem about OpenAI. So you can see very quickly if the model is going to be, oh, future so bright. That's got to sting. But you can see it's, oh, fish sticks. You can see that it's very good in general. So that's why I like this one. It's been trained in a way that responds more like what you would expect. Smaller models don't necessarily have as much knowledge, if you want to think about it that way, as some of the bigger models, but that's where things like RAG, which is retrieval augmented generation, comes into play, and things like embedding more defined prompting instructions and examples. So not just RAG, so not just looking for knowledge bases or information, but also making sure that you prompt it very correctly, which you have to do with ChatGPT-4 anyways. So this is just a little bit more hands-on, but if you're a developer, I'm sure you can handle it. If you're not a developer, then it's still one of those things where it's more easily accessible to somebody who's looking to get into a business where they want to host their own models. Okay, so first thing you want to do is make sure that you install some of the requirements. Here are the ones that we're going to be using. PyWebView is optional if you actually want to run this as its own standalone app. I showed a video previously as far as how you can do that. For the sake of the LLM, all we need is C transformers. C transformers is something that you have to install very specifically if you want to use it with GPU acceleration, which you probably will. If you have a very beefy CPU, you might get away with using these smaller models, especially the quantized models, without needing anything special, but odds are you're going to want to run it on a GPU. In the case of NVIDIA, it's usually just adding CUDA to the end of a lot of these packages. This is what you're going to want to use if you have an AMD CPU. Have not tested with AMD GPUs, but I do have Metal. So that is Apple. We're going to be doing that. And then GPTQ, I haven't tested. That's a different format. So there's GGUF and then there's GPTQ. And I think there's one more, which is AWQ. Or something like that. I haven't tested those out. Usually what I go to is straight for GGUF or GEML, which is Llama CPP, Llama C++ stuff. So go ahead and make sure that you install the version that you need for your system. In this case, I just left it blank just so we know that we have it there, but you can replace it here for whatever you need. And once you have that installed, that's the major requirement. The other one that we have listed here that we'll need is LangChain, and this is kind of an optional framework, but it is very helpful because they already have a lot of the nuisances already built into it. So you have things like templating and retrieval systems and conversation windows and all that kind of stuff. It makes it a little bit easier, especially if you're starting out, to get into a more ChatGPT-like flow where everything from start to finish is a little bit more robust. I have mixed feelings on LangChain just because there's a lot of extractions that don't necessarily need to always be there. It does do a really good job at keeping things consistent across the board. So if you have a team of developers and you want them all on the same page, this is a really good way to do that unless you're going to make your own simple library in-house. Okay, so let's create a file to go over what's exactly happening behind the scenes. So the first thing we're going to want to do is import C transformers. And the way you do it fairly easily is with the auto model for casual LLM. That will import a lot of the configurations that you need to actually get it going. And then we're going to tell it where the model is. This can be a Hugging Face, repo ID, or it can be something local. Since we're doing locally, we need both the model path and the model type. And then we're going to go ahead and we're going to create the LLM. So we do an auto model for casual LLM, and we're creating it from a pre-trained model. And we give it model path, model type, and that's essentially it. Okay, and the only thing we actually need to do in order to get output is just essentially this. So we're going to give it to a variable. So response equals, and then we are going to print that response. I have Copilot helping me out. So now if we run that, it should load the model. It'll give it the prompt, which in this case is just hello, my name is. No instructions. It's just going to try to autocomplete that probably. And then we are going to print that out. And you'll notice that we actually don't get any feedback. It's going to do whatever it's going to do. And then as you just saw, it just spits it out to the screen. And it's basically trying to do what all LLMs actually do, which is just autocomplete. So we started with hello, my name is, and then it says Nia, and I'm 25 years old, been working in the field of customer service. So you can see kind of what's actually going on behind the scenes with most LLMs. This is just how they work. When we actually give it proper prompting and instructions, that's when it does things a little bit more structural. But how do we actually get this to print out in a way where we can get word by word what's happening? Well, that is with generators. And beforehand, I actually went ahead and asked ChatGPT what would be the easiest way to explain generators. And it came up with this, where it said, generators in Python are like a lazy chef in a restaurant. Imagine you order a multi-course meal. Instead of cooking everything at once and bringing it to your table, the chef prepares and serves one dish at a time. After you finish each dish, the chef starts preparing the next one. This way, the kitchen doesn't get overwhelmed with work, and you get each dish fresh and when you need it. In Python, generators work similarly. They handle data one piece at a time instead of preparing everything up front, which saves memory and make programs more efficient. All of that's good and well, but what we actually care about is the fact that it spits things out as it comes along. So to give you an idea of how that actually works, we can create a function. So we'll just call it generate prompt. And I'm going to get rid of these things that Copilot created. We're just going to get rid of that. We'll take that same string that I showed before about the explanation for generators, and then we're just going to return for word in output dot split by space. We're going to return word. And actually, we'll do a from time import sleep. And what we're going to do here is we'll just give it a sleep of 0.1 seconds. Actually, we'll also import, so from random, import uniform. And uniform is like it's kind of like random int, rand int. So, but instead of a random interval, you can get a float. So what I can do is sleep for a value, so uniform between half a second, we'll say 0.1 and 0.3. So we don't have to wait for it forever. So it'll sleep a little bit. And actually, we won't need a prompt for that. So generate, and we'll print the output of that. And then now if I run this, I'm going to move this over to the right. Actually, we don't need that anymore. You get the idea, right? Like it's intensive. So if we do this Python CLI LLM, we just get generators. We get the first word. And that's because a normal function with a return statement, it ends as soon as you return. That's it. You're done. With generators, what you do is you use yield. And then now you can iterate over it. Now, if I run this again, it's still going to give me just the generator object. So what I end up having to do is for word. So for word in generate, now we get to iterate over it just like we would a list or any other iterable in Python. So if I go ahead and do this, then now we start to get that streaming effect that we're expecting. Now it's doing it one at a time. It's printing it on a new line. And technically that's what's happening with the LLM, but we don't need that because it's kind of gibberish right now. Nobody's going to read it that way. So I'm going to stop that. And then we can go ahead and do something a little bit more meaningful. So if we're running this as a message, and what we do instead is message plus equals word, and then I guess we can give it a space because we cut out all the spaces so they don't end up being jumbled. And then we print the message instead, and we run that again. Now we start to get that more familiar response. Now, obviously, the rest of it is kind of intense. So what we can do is import OS. And then we can make sure that before we print the message, we clear the screen. So os.system_clear. And then now if I run it, voila, we get the thing that we're expecting. We get that response where we have each word coming in as we go. So that's why it's important for you to understand generators, because this is essentially how it's going to work with the LLMs, with the difference being that we are now updating the UI. Okay, I'm going to go ahead and move this to be a little bit cleaner. And then I'm going to comment out the rest of this. I'm going to paste in this example that I have here where it's using the actual LLM. So similar to before, we're just going to be doing this input. So we'll just say input from user. And then we're going to stream equals true. And that's what's going to enable the streaming functionality of this LLM generator. And we're going to be doing the same thing we did before, where we're using ossystem.clear in order to get rid of all the stuff that we see beforehand. So now if I run it, we actually get an input. And if I say OpenAI is dying, Poor rip OpenAI. It's going to have to take the time to actually load it into memory again. And then once it's done loading, that's when we're going to start seeing actually output any kind of responses. So on an app like this, where we actually have a GUI, an app like this on the left where we actually have a GUI, then we will, there it is. Apparently it thinks it's a tweet. That's fine, but we didn't give it a prompt, so that's kind of what it is. So actually, if we go ahead and do something where it's a little bit more prompt-like, where we say something like prompt is going to be equal to an f string with lowercase f, right? And maybe what we want to do is you're an answer, you're an assistant, if I know how to spell. See if Copilot will do. Okay, it didn't do anything. You're an assistant to an executive at a, oh, there we go, large company. Answer the following professionally. And then we could say that we want user. And actually, since this is not a LangChain template, we have to do it from before, after. So I'm just going to paste it here, give it an indent, and make sure that we're passing in that user. So essentially, we'll have this prompt, and then we'll give it whatever it is that we're typing in, and then it's going to pass all of that into the LLM. So if we go ahead and run it again, what is a coup? Because that is clearly the topic of the week. Again, since we're running the script from scratch each time, the first time it's going to take the longest because it has to go through and load the model and add everything into memory. But you can see it's actually pretty snappy. So a coup d'etat, and it goes through and it does its stuff. It's going to start spitting out stuff forever. As it comes in, it's just going to be doing its thing. And I'm going to let it finish just so we can see that the second time around, it's actually going to be a lot snappier. It is actually a little slow right now because, again, I'm running OBS Studio. I'm doing all this stuff at the same time. I have another instance of VS Code so I can see some of the examples. What is bacon? The other thing you'll notice is that we don't have any memory. We're not actually giving it access to the previous responses. So it doesn't know. What was that? What is gravy? Gravy is thick, so it can answer. It has a pretty good amount of knowledge. It was trained on a pretty good amount of information. That's why I really like this model. What is a Python generator? So here we go. So it has a really good understanding of a lot of things. It just doesn't have as much internal, I guess, knowledge. It has reasoning. It doesn't have as much internal knowledge as some of the bigger models where they're basically feeding it the entirety of the internet. We don't have that here. So what we do have, though, is a very good reasoning agent, if we want to use that word, that can understand instructions and it can understand what it is that we're expecting. So as long as you're prompting it fairly well, then you can even reasonably well, it's doing pretty okay here. We can get responses that we're expecting. So like create an ad for create an ad for Twitter that is for a fitness brand. Get in shape and stay motivated with our fitness goals, our hashtag fitness goals. Follow us for workout tips, inspiration, and more. Hashtag sweat more, love fewer. I don't know if I get that one, but sure. And now create the headline for the ad. So it's actually going to keep going. So it didn't stop. We haven't told it where to stop. We haven't told it where to keep going. But this is a pretty interesting way to actually have something run locally that you can, if you're running this over a campaign and you want to have selections, you could have this script just generate 100 or 200 of these and then have your, not client, but you would probably have somebody go over them and pick out some of the best ones. And then you can actually fine tune off of that. So it's a little bit of an iterative process, but this is essentially what OpenAI had to go through in order to get ChatGPT to be as good as it is now. So now you get to have some of the fun on your own. So now that we understand what's going on behind the scenes, we understand generators, we understand how the LLM is actually streaming some of the responses, and how all of that is working, let's move over to the HTMX implementation. Okay, now in our index.html, we're going to start getting everything ready. We will do the usual setup for doc type of HTML, and we will start adding things to our head. Titled it very appropriately, OpenAI, which is what I think I'm gonna call this if it's not already available on there. We have the usual stuff in the head. We're gonna import Tailwind. This is an older version because when I originally put this together, doesn't matter, old version of Tailwind. We have highlight.js. This we're not actually using right now, but this is what OpenAI does use for ChatGPT to get the highlighting for a lot of the markdown and coding and all that kind of stuff. But I figured I'd leave it there so that you guys know that's something that you have an option to use. So there's a CSS style sheet for that, and then also a script that will do that. We also have font awesome, and that's going to be for the arrow thing, the arrow/send button. And then we obviously need HTMX. And more specifically, we need HTMX SSE, which is server-sent events. And if we take a look at the documentation for that really quick, so it's just like any other HTMX arguments where you add them directly to the element that you want to use this with. And it's fairly straightforward. There is a little bit of background on server-sent events that you might need to get into if you're looking to add multiple of them, but we'll take a look at that in a second. Continuing the index.html, we need a body, and we have some Tailwind things. You can ignore those because that's more a stylistic choice depending on what you want to do. We need a main container for this. So this space up here in the GUI is actually a list, and that's where all our messages are going to live. So we're just going to add that. We're going to give it an ID of chat responses. We're going to enable server-sent events. We're going to tell it how to connect. So it's going to be endpoint/stream. We're going to tell it what data we actually want to swap out. The default for the data coming from server-sent events is going to be message. But if you wanted to place it somewhere else, you wanted to have a few different containers, maybe pop-up notifications, that sort of thing, then you would change this, and then you would also change it on the stream endpoint. So we're going to tell it where to swap things in. So before the end of the container, we're going to give it some classes for Tailwind styling, and then we're going to move on to our actual input, which is this form at the bottom. So we're going to go ahead and we're going to give it an ID of chat. We're going to give it some Tailwind classes. We are going to tell it where to post. So there's going to be a separate endpoint. There's going to be HTMX submitting to chat submit. We're going to tell it what to target. So we don't actually need the target because we aren't normally expecting a response, but for the sake of getting error messages, so if it can't complete the message or if we didn't send the right kind of input, I added this. So whatever messages we do get that we set up on the server, we could send it back to the chat box as well. And we are also going to swap it before the end. So the trigger is going to be a click from submit button, and that will create in a second, but that's the little arrow thing here. So before I created the server-sent events version, I didn't have that working, obviously. So I needed a quick way to get the current inputs into the chat. Probably don't need this now because we can also add these on the back end to the chat and it would just stream everything together. But in case you were curious, we're just going to go ahead and add an event listener for HTMX before the request. Let's find the chat box and let's add a list item with the current value of our input, so our current message. And then we're going to go ahead and empty the input and we're going to add our placeholder back. So this next part, I don't remember if it's actually working, but I'll add it because that's another way that you can actually do controls. So window.scroll, and then we're telling it to find height or whatever. I don't think that's actually working. I'll leave it in there. HTMX.find, and then we're going to focus on the input, the user input. And then after the request, scroll. So I think I was just trying to get it to auto scroll, and I don't think either of these ways were actually working, but I'll leave them in there because technically they could be useful for you at some point for something else. And then we're going to need a text area. And this text area is going to be our actual user input. I'm using a text area instead of a regular thing, just so we have a few more rows and a little bit more controlled. Autofocus, autocomplete. I don't think these actual extra ones were needed. I don't remember why they're actually, so autocomplete off. I don't remember why I added that there. It doesn't matter. ID of prompt. And so we know actually where it is. And then we have the name of user input. So on the back end, there are two IDs on this thing. Cool. So we'll pretend that second ID actually isn't there. And then we're going to add the button. And then I added this little bit of JavaScript just to make sure that when we press enter, that we send the HTMX request. So originally I had this file called AI response, and I was using that to send all of the AI responses. But now that we're using server-sent events, what I ended up doing was just adding this straight into the streaming endpoint, just because it's a little bit easier to do the replacements that way. So we will do that next. Okay, so in our main.py, we're just going to start off with the usual thing. We'll get our imports. We have a bunch of stuff coming in from Flask. From here, the only important one, which we'll touch on in a bit, is stream with context. And we have to import Q. That's what we're going to be using for actually getting our messages. We're also going to import random because we need a random number later for something. We could use the UUID, but whatever. We're going to do the same thing where we're importing auto model for casual LLM from C transformers. Assistant prompt, we haven't created that yet. I'll make that when we get to it. Just going to add some variables for things. So my username, my AI name, you could add these to an environment variable. And in fact, for the version that I use locally, I do. It was just easier to have this all in one script. So again, model path, model type. We're going to go ahead and instantiate that queue. So for history, LangChain does have its own conventions, but for whatever reason, the conversational chains weren't working with streaming when I tried them. So for history, we're just going to create a list, and that's just going to hold all our messages, and then we're going to feed the last, X amount of messages into the LLM. So we can instantiate our Flask app. We're going to print model loading, and then I'm going to create the model, and then I'm just going to say hi with a max new tokens of 2. And this is when we start saying the parameters that we can pass into the LLM for how many tokens we want back, the temperature, which is the creativity or randomness of the model, that sort of stuff. I'm passing it in for 2 tokens just so it can get into RAM and then just do something, make sure it's there ready. And then I'm going to say model loaded. We're going to create the function for actually processing the input that we get from the user. We're just going to take in the user input. In this, we're also going to go ahead and pass in some other variables that we want to give to the LLM. So max new tokens, the repetition penalties, those sort of things. Stop words is essentially when you get to this word, stop. If you've ever played around with the OpenAI playground, then you probably are familiar with some of these. If you haven't seen these before, these are just a long list of parameters that you can pass into an LLM in order to get the right expected responses. We're going to go ahead and put this in a try and accept just to make sure it doesn't explode like OpenAI. Wow, too soon. We'll add a message window of 15, and that's just how many messages we're going to feed into the model from our history. And then I'll go ahead and join all the history items once we actually add them to the list with a new line. So each instance will be on its own line as a string. And then we can make sure that we use the negative message window as an index. So from 15 before up until the end, send us all those messages. The prompt, so next we'll add our message, and this is going to be similar to that command line demo from earlier where we're just adding the words as they come into the message before sending them out. And we will iterate over the LLM streaming. This time we are passing in all those arguments. We could also unpack this if you wanted to, but I wanted to be very visual for how we're actually doing it. And then we'll do the same thing, message plus equals word. So we're just going to keep adding the words as they come in, and we don't have to add a space because the LLM will actually add tabs and spaces and all that stuff to the string as well. We're going to print it out just so we make sure that when we run it, you can troubleshoot to see, like, is it actually spitting something out or is it not? And then once it's actually generated the message, everything's done. At this point, user has already seen it in the client side. We can go ahead and add this to the history. Then we'll go ahead and add our exception. And this is just going to be, hey, we can process this. Okay, we're going to create our home route, our index, and then we are going to clear the history. We want to make sure that if we refresh the page, we're not using the same history from before. We're going to return the index.html. Here I have username and AI name. And the reason for this was in a different version, I did have it say your name before you even started, or it have the, hey, you're chatting with X. So you know that if you change different prompts or if you change different AI names, you know who you're talking to. We don't actually use it in our template now, but I figured that's a good way for you to think about it. If you want different conversations to have, different personas, you can add it that way. And then we'll go ahead and we'll create that chat submit route, which is what we're actually going to be posting to from the form. So this send message thing will actually go to chat submit, and we're just taking that user input. If there's no user input, then we're calling it AI response, but it's just response of, hey, just add something valid input. We did take care of this on the front end. So you might not necessarily need this. This, again, I'm just leaving it in there because if you did want to have some kind of validation on the back end, then this is how you might be able to do that. And then we're going to give the current response. an ID. And this is important because of the fact that we're going to be using out of bounds swaps in order to make sure that we're clearing the previous message. So on the command line, we were using system clear in order to make sure that we are not just having this long trailing tree of, messages. We're going to be doing something similar like that to the chat, but we're just going to be getting rid of the current message that we're working on. So we generate a random ID, and then what we're going to do is we're going to render that response with that information. So then we're going to make sure that we add that to the queue. So we're message queue.put, and then we're going to put in the user input. And this is how that streaming method, which is separate to this, is going to be able to find that last message. As soon as one comes in, it's going to be able to pop it out, start generating a response. And then all we're doing is returning success in 204, just so we have something we know on the front end. Hey, something happened and it was good. Now for our streaming endpoint, we can just call it stream. Nothing special has to happen with this. It's not a WebSocket, so we don't need anything fancy. We just /stream. I'm going to call it stream because that's better that way. We're going to define the generator essentially that we're going to use. Now you don't need this stream generator if you're just going to call it from the LLM directly, but since we're going to be doing some extra stuff to it, and we're not just popping out the words one at a time, we're going to create our own generator built on top of that generator. So I'm going to call this global new conversation. That actually isn't needed. That's a thing from an old, I'll get rid of that. So while true, so it's going to keep it going. It's always going to be checking that message queue. If it's not empty, then we're going to get the last message. So message queue.get is going to return the last one. So it's last in, first out kind of thing. And then we are going to go ahead and create we're going to create a random ID. This is a separate function. So we got to make a random ID. HX swap equals false because the first one, I don't want it to have the swap enabled. So we'll do the same thing again. We'll create a message. The previous one from that chat response from the other function was just so that we can have it and add it to the history. Technically, we could do it here as well, but normally if it was going to be something where it lived in a different module, you would probably have it all self-contained. So I wanted to keep that logic going here. So we'll create the message and we're going to iterate over whatever we're getting back from that chat response. And we're going to do the same thing. So we're going to try, and what we're going to do is replace a new line with a break. Just so that it doesn't stop preemptively. I ran into some issues where it wouldn't, on the front end, return the entire message if it had a new line instead of a break. And then we're going to go ahead and we're going to create the message. So this is actually where we're going to see the robot's name or the AI name and then the message. So the next thing we'll do is return the actual list item, but we have to return it as JSON in this way. So if you'll notice, we have data and then the string for our object, followed by, and this is very important, the two new lines at the end. For whatever reason, it wasn't working unless I sent those in. But you'll notice that on the left, we have also this extra parameter that we can send called event. So this is what I was mentioning, where if you want to have multiple different streams going on at the same time, then you can absolutely give it a different event, and that'll be for notifications or whatever it is that you want to have updating at the same time. This is also an alternative to that polling video that I put up a few weeks ago, where we're checking an endpoint every second, every 10 seconds, every however many seconds or time that you want to check. You could actually have this where it's just connected to a stream, and whenever, for example, in the case of that video, a chart updates, then we can just update that. So you would just give it an event. So the default is message, so that's why I'm not passing one in here. But if we did have, for example, a chat, and then we had notifications, and then we had, Bitcoin, like whatever, it doesn't matter. You give it an event, and then this will know which one to get by that SSE swap that we actually gave in the template. And then we're going to add this little if statement, whether we're going to actually add that out of bounds swap parameter. And this is based off this variable up here, HX swap. So if it is true, then add this. If it isn't, just empty string. It'll just be null. It'll be empty. And then we set it to true. So it'll only come back as false on the first time, and then it'll be true. And then we're going to print it out just so we could see what's going on in the terminal. You could also do logging if it's something that you want to keep a history of. And then we're going to yield that. So this is what instantiates our generator basically, and we're going to have exceptions that are printed out and returned if we have any issues with that. And then we're going to return the HTTP response, which is going to be app.response class, and then we give it the stream and a MIME type of text event stream. Now, and you would assume that this is all you need to get it working, but Flask needs context for whatever reason. So if you do stream with context, it's going to make sure that it has access to that request object for if it needs, for whatever reason, any of those things inside. If you do this, that's essentially it. So if we run this code, so Python, and then this is main.py, it will break because we forgot to add the prompt. So we'll create a new file called prompt.py, and I'll just paste this in because it's essentially just an f string where we use these placeholders for any information that we're going to pass in. And the difference you'll notice here is that it's not actually an f string here. So that means it could actually be anywhere in a separate module like we do have it here, or it could be in a different part of your app. It doesn't necessarily matter. And then for you to actually render it, what you end up doing is this passing it into this prompt template where you give it the input variables and you give it the template, and it'll make sure that it's doing all the stuff itself. Okay, so if we run it now, look at that, model loading, and then I'll start popping stuff in. And then if we go to 9898, which is what we called it down here, first thing I added to the script, we're there. So if I reload, this should work. So if I send a message, wow, that was the wrong hi, and then send that in, and we see that HTMX on the front end with those event listeners is adding it to that chat messages, and then it's getting sent to chat submit, and we're running into the issue. Oh no, okay, so it is starting it. Okay, so I restarted the script with this HX swap off, and then you'll notice that when it starts spitting out information, we're actually going to get a million messages popped up to screen. And that's why I did it this way. It was a little easier to just grab the last message we're working on based on that random ID, so that we don't get that weird, tree of messages in this thing. I don't know. So that's why I did it that way. So what it's doing is with the HX swap set to this kind of format where it's initially false, and then I technically don't think it needs to be false the first time. I just didn't have enough time to play around with it. It's just grabbing this one right here. So this has its own ID. And if we actually inspect this, you can see that they all have the same ID. So as long as it has that swap set to, and they actually have different IDs. So this first one at the top will have its own ID. So this is 469, and then up here, this is 703. That's why I'm generating them random like that. And it's similar to something like what React would do behind the scenes for stuff like that, to know where your ID is coming from. So that just means that we're going to swap it so we don't have this mess, because you don't want that. And that's kind of the only thing out of the ordinary. So streaming is going to work as it should, just the way we set it up. The important thing is to make sure we're using a generator. If you don't use a generator, then it's just going to like wait for it to finish, and then it's going to send it back, and you don't want that. You want things as they come in. So this should have actually restarted, but I'll go here. I'm going to go ahead and paste this run.py, which is pretty much similar to all the other ones that we've had in the other videos for using WebView. But if you're not familiar, we're just importing PyWebView, which is essentially just a browser window in that form. And then we're going to make it so that it runs this main.py file in a window. So if I run this, so close this out, Python run.py, if all goes well, then we have this same situation here where it's running an LLM locally on its own device, except it's in a on its own window. So if I go over here, you'll see that it's the same thing. So hello, and we'll run it there, and it'll do the same thing. It has it scrolling. I don't have it set by default to be a tall thing because for the sake of demo, it's fine. Usually I do have it like this. And there you go. Now you have an app that you can put anywhere on your thing, and it's just like, what is it? And it's usually very snappy. It's not super snappy now because I have a lot of things going on. But also, if you were just going to use this to programmatically make stuff that would be, generated in HTML for the sake of, I don't know, marketing materials or just informational things, retrieval stuff, research, then you wouldn't need this app window. But I like having it here because it's just, you could add it to an icon, launch it, and it's just pretty cool to have. That's pretty cool. So hopefully that was helpful. If you have any questions or if you want to get access to the code, then you can, check the links below. If you want to subscribe to the Patreon, that's probably where I'll be taking requests for any things that we want to add to it, or if there's any updates to it, I will try to release it there first. I'm trying to start to get active with the Patreon thing. I haven't actually done it before. So if you want to check that out, you can do that. And if, like, subscribe, do all that fancy stuff, any relevant links I'll just have in the description below so you can check that out. And I will catch you guys on the next video.